Hey, David. How you doing today, David? I'm trying to recall if you guys have picked an experiment yet or not, or whether you're still having a little difficulty choosing one. I've had a lot of good ideas that people came up with, and kind of anxious to Kennedy's in the house. Kind of anxious to see some stuff come back from you guys. Say hi to Harold. And I know there's a few people in Terra who have asked me what they wanted to do, and I gave them approval, and they started their experiments. Some have even posted video already to me, and kind of what we're waiting on is the written portion of it, which is also always a little bit of the difficult part. So what we're going to talk about today is we kind of have gone up to the point where, and I'm looking over at my other computer, because I posted that project timeline. It was 5 sheets, and page 2 was a project timeline to give you guys an idea of the step-by-step instructions and research question. In other words, what is your question going to be about? Doing background research, writing your hypothesis and explain why you think, writing a material list, writing your procedures out, which in and of themselves can be difficult, or they can be rather simple depending on your experiment. And then actually conducting your experiment and making sure that you're recording your results. We've talked about all that and how that all comes up to the point where you're going, okay, I had a question. Okay, for example, I had a question that I wanted to see what would work best to get a permanent marker out off of a shirt. You'd say my little brother, my little cousin wrote on my shirt, whatever. And this could be real life, but let's say we had an old shirt that we don't fit into, or that we don't wear anymore for whatever reason, and we want to take a bit of it and maybe cut off a sleeve. Let's say it's a white shirt, and we can cut it into little squares and use our permanent marker on them and mark it up. And we're going to see if we can find some sort of household item that we have lying around the house that'll get that permanent marker out. Okay. And so that was our question, and we've gone through, we've found some stuff in the house that we can use. Maybe we're going to use a dish soap. Maybe we're going to use vinegar. Maybe we have some hand sanitizer. We're going to try maybe some isopropyl alcohol, whatever it may be. You find something that you decide you want to use, and you have your samples set up. Let's say you're going to pick 3 or 4, and you got your samples set up, and you've done all that, and you're recording your data. You're doing the experiment. You're timing how long you're putting it in the sample, what it is. Sample A is dish soap. Sample B is vinegar. Sample C is hand sanitizer. Whatever. Just hand sanitizer is kind of hard to come by today, but so if we have it, we might necessarily want to don't want to use it unless you're hoarding it and have a lot. But you understand what I'm saying. You got your samples, and now you're going to record. You're going to observe it, in 1 hour, and write down observations. No change. 6 hour. Blah blah blah. Some change in sample 1. No change in sample 2. Change in sample 3, and then 24 hours. The stain is completely gone in this sample. This next sample, nothing happened. Whatever, you're recording your data, and then you're kind of like, okay, what do I do now? I have all this information that I've gathered. How do I take it and make something out of it? Well, there's a couple things you can do with it, and one of the things that I'm going to talk about is one of the ways you can put information would be to actually create a graph. Now, if we were at school, I'm trying to get you guys more sophisticated, hopefully more sophisticated than I am when it comes to technology and using technology. I was sitting here thinking, okay, if we were in class, the students would get some graph paper, and they might make their own graph on the graph paper and turn that in, and that would be part of their grade. I thought, can they do it digitally? Well, if you type into your search engine, whether it's Google or something else, if you type in bar graph, gotta spell it right, Mr. Soriani, bar graph maker. Okay. There are all kinds of free bar graph makers. Okay. And so I created a fictitious one. This is the same bar graph. You can tell I'm out of ink, out of colored ink. So I did it in black and white. And I did this and this was fictitious. It's student work and number of students that have completed assignments. It doesn't represent anything real. It's just something that I created in about 5 minutes. I really did this in about 5 minutes. And so these bar graphs can show different amounts of information based on how you want to set it up. This is a really good way of going from here are my results that I've been recording with a pencil on a piece of paper to how do I present it to the class. And absolutely, Kennedy, because the 6th and 7th graders are basically doing the same. You're doing science experiments, and so you need to share your results. And either way, you need to share your results. And next year you'll be doing something similar to this, although it'll be on a little bit different level, a little bit more complicated. But here's an example of the graph. Like I said, bar graph maker. I did it. I Googled it. I picked one, and I did it in about 5 minutes. And so I have a way of expressing my information. It's really important when we're doing that we go, okay, my question was whether I could get this permanent marker out of my shirt. Well, yeah, it was a little piece of cloth. Hey, Dimitri. But that was my question, right? And so I cut out a little piece of this shirt up, got my scissors, cut up a little piece of shirt, and put it in a container of some sort, put my liquid in there, and I let it sit for 24 hours. And I'm going to put it in a container of some sort, put my liquid in there, and I let it sit for 24 hours. And I'm going to, you're going to be doing this like this, okay? And I'm going to give a shout out to Dimitri, because Dimitri asked me about an experiment. We talked about it. I gave him, excuse me, I gave him an approval, just like Lucas did the same thing, and some other students as well have asked me, this is what I want, this is the idea that I have, this is what I want to do. And I said either yes or yes, but focus on this. And so I've already gotten a video of Dimitris' experiment, which was really cool. And so now I mean, his thing now is to say, okay, so he did it, right? He needs to go back and say, you know, what did I think was going to happen? You know, what was his hypothesis? And then when he gets down to that part, he's going to say, okay, this is what happened. Is there a way to show it? This is what happened. Why do I think it happened? And one thing, he's got a lot of time that he could do. Okay, one thing that he can do that will make his experiment a little bit more complete is, I'm not sure if I saw more than one sample. And so what he could do is do the same thing over in a different liquid and see if there's a similar result or no result. And so he can compare and contrast, and then draw his conclusion. Can he make some sort of a graph from the information? Can he make a pie chart, or does he just have data points and he's interpreting it? Here's where your brains come in, right? Here's where you're saying, you know, I got a totally different result than what I expected. And I think the reason that happened is because of this. You know, maybe this happened because of the way the ink is. You know, maybe the ink only works with only a similar product will get the ink out. Maybe it needs to be an oily product to get oil out. Maybe it needs to be something similar to this to actually get it to come out. You know, you're churning, you got wheels going off in your brain going, okay, here's what happened, here's what I expected to happen, and here's what happened. And it was totally wrong. Understand, I really kind of expect you guys to not necessarily be right. And then maybe you were in the right ballpark, but not necessarily right. So if you go back and write your hypothesis after you've done your conclusion and you've written your hypothesis to match your results, let's be serious. Did you really expect those results? Because a lot of times you're going to get results that are what we call counterintuitive, or the opposite of what we might normally expect to get as far as results go. And so be honest about, you know, what you're expecting to do, expecting to see, and then what you really saw. And if it was totally different, that's fine. Then there's that part where you say, like where you're showing your results in a graph or a table of some sort, which is why you had all that stuff in the packet that we sent home, the second Blizzard packet, so that you get used to using those graphs. And then you can say, I did these, I looked at this line chart and this pie chart and this graph chart and this bar graph, and I think the bar graph would be most appropriate and easiest to use for this, for me to show the results. If you don't want to get on the computer and do it, and you want to draw it on a piece of paper and take a picture of it, fine. I don't really care. I just think it's pretty cool that I was able to make that in about 5 minutes. You can go through all the steps, right? You can go through all the steps of your lab and honestly kind of write a crappy conclusion, not really explain what happened compared to what you thought was happening, not talk about if it didn't work right, what could I change, and you could lose points. Each one of these sections is worth 15 points, and so if you really blow a section, that can blow a perfect experiment and a perfect grade. It isn't so much about, do I have to get an A+ on this? Do I have to get every single point? It's not really about that, but it's about process. And if you do everything right and you're not showing me in your conclusion that you understand exactly what happened, I probably am going to, not necessarily sending it back to you, but yeah, I guess so. I'm going to be sending you a comment or a question. What about this? All right, I got this from you, but I don't quite understand. Why do you think you got this result? Because you haven't given me an opinion on something that I'm expecting to get an opinion on. Why didn't you tell me about what happened? Like we were talking about getting a stain out. Oh yeah, B and C both got the stain out, but something happened to the shirt in sample C. So maybe even though it worked, we might not want to use that because it'll end up ruining the shirt anyways. And we think, oh, a shirt is ruined if it's got a stain on it. Oh yeah, I can get the stain out, but if I did something to damage the cloth, then it's maybe ruined anyways. Is there a difference in how it would react? How might you want to change the experiment to make it work? If it didn't work, then part of your conclusion would be, well, my experiment didn't work. I think one of the things that I can change to actually make it work is to do this differently. Boom, then you're going back up to the middle of your whole scientific experiment, and you're going to change that variable. The V is for variable, and you're going to redo the experiment and see whether that actually changed everything, and whether it worked by changing that one variable. And so scientists do this, and they'll go and they have a hypothesis. They have a question. They come up with a hypothesis, and it fails. And they think, okay, what can we do differently? And they come up with a different idea, and they redo the experiment, and it fails. And they analyze it, say, what can I do differently? And they do it again, and it fails. Okay, I'll make it less crappy. Well, don't think. And first of all, understand that I've got a daughter that will turn something in, and it's not bad, but the teacher knows that she could be more clear or do better on a certain section. And so I'm the same way. Don't necessarily think that if I make a comment on it that it's completely wrong. It may be that I'm saying, yeah, this is good, and I may be saying to myself, this is good, but I'm wondering if you're understanding something else. And maybe I'm going to add another question to make you think a little bit deeper about it, because I think you can understand where I'm going with it. And so maybe it's about me making sure that I think you understand. The whole purpose of us doing these experiments, it's not about getting a grade so much as it is about you guys understanding the process and becoming thinkers and learning how to think through things solve problems. Doing scientific method is really about solving problems. This is something that's going to help you in your lives totally outside of science. And so we go, that's not why we do it, but it's something you're going to take and apply somewhere else. A lot of times when you're sick. Sometimes we get what we call a unexpected result. In medicine, it's a side effect, and sometimes you hear people say that the cure is worse than the disease. When I hurt my foot, the doctor gave me some medicine because it hurt really bad, but the medicine made me really, really sick to my stomach and dizzy, and I just constantly felt like I was going to throw up. And so for me, that was worse than, the pain. And so I didn't take the medicine because of that. And so that was unexpected consequence. So sometimes when we're doing an experiment, we get an unexpected consequence. And for you to say, oh, I didn't expect this, I'm not sure why it happened, maybe because of this. And if I did the experiment over again, I would change A, B, and C. But only one of those at a time. I would change A, or I would change B, or I would change C. And so looking at your results and analyzing it and really being able to understand what happened in your experiment and why it's important to explain that. And so a lot of times I will just try to make sure that you understand it. I see a squirrel going down the tree in the background. Just make sure that you understand it as much as I think you understand it. And a lot of it might just be in your explanation. You might actually understand it real well, but you just didn't verbalize it. And I know we all have different levels that we communicate on. Some of us kind of are just better at talking and explaining, and typing things out is a little bit frustrating, but work through it. We got time. This is our big project between now and the end of the year. If you're planning on doing it this week, that's absolutely fine. If I've looked at your experiment and said it's awesome, but I have some questions about it, don't panic about that either. Just know you got plenty of time to do it and get it done. And these are gonna be great. What I've seen so far is great, and I really appreciate the people that have put some effort into these. And make sure you're communicating with me in Google Classroom or by email. Other than this weekend, which I was out of town, we've been communicating quite a bit. Some of you are early risers, and some of you, honestly, I've gotten messages at 8, 9, 10 o'clock at night from students. And, I'm not sitting in front of my computer, but, if I check it, on every hour or every couple hours, then I can actually respond back to you guys. So a lot of good stuff coming my way. I'm excited about. Make sure you're taking pictures and or videos, of which I've gotten some, which were really cool and fun to watch. It makes me really, really miss you guys. And it makes me sad that we're not doing this in the classroom, because this is one of the, for me, this is one, and for Mr. Fosnight too, I know, this is one of the best times of year when we get to see you guys do experiments and discover, especially when we throw it on you to come up with your own idea. If you're still struggling with an idea, or if I haven't heard from you, I might actually be messaging you or trying to email you. So be prepared, because we are getting close to the middle of the month. I hope you guys are doing great. I'm going to get off here, and we'll talk to you guys. See you on Thursday. Peace out.